The viscous laminar flow of air over a flat plate result in the formation of a boundary layer. The boundary layer thickness at the end of the plate of length L is delta L. When the plate length is increased to twice its original length, the percentage change in laminar boundary layer thickness at the end of the plate with respect to delta L is. So we need to find the percentage change in boundary layer thickness at the end of the plate when the plate length is increased to twice its original length. Let's understand the boundary layer thickness over the flat plate. Now let's say this is the flat plate and this red curve represents the boundary layer over this flat plate. Now suppose at distance x from origin, we have taken the starting point of the plate as the origin. So let's say at a distance x from this point or from this origin, the thickness of boundary layer is given by delta x at this point. Now let's say the total length of this flat plate is L. So at the end, the boundary layer thickness will be delta L. So the laminar region of boundary layer on this flat plate, from the experiment it is found that it varies. Delta x is equal to 5 into x divided by square root of Reynolds number at that point. So at x, the Reynolds number is given by Rex. Okay, and this is called the local Reynolds number, and it is given by Rex is equal to density, that is constant, the velocity of the flow, and the length x from the origin or from the starting of the flat plate, x divided by the coefficient of viscosity. So this is called the local Reynolds number. From here we can see that x, the boundary layer thickness, varies only with x. So if we substitute this value of Reynolds number here, we will find that the boundary layer thickness is directly proportional to square root of x. Now if x is equal to L, that means at the end of the plate, let's say this is equation number 1. So we can write this equation number 1 as delta L, because here x is equal to L, will be proportional to square root of L. Now in the problem it's given the length becomes twice the original length. Now according to problem, if x is equal to 2L, then delta L will be proportional to square root of 2 times of L. Now let's say this equation is equation number 3 and this, let it be equation number 2. So if we take the ratio of equation number 2 and 3, we will get delta L, that means boundary layer thickness at length L, divided by delta L of second plate, that is we can write delta 2L. So here also we can write delta 2L. Okay, this should be equal to square root of L by 2L, that is 1 by square root of 2. Let's say this be equation number 4. Now we need to find the percentage change of the boundary layer thickness. That means we need to find percentage change. Percentage change of boundary layer thickness will be delta 2L minus delta L divided by delta L, because with respect to the boundary layer thickness of the original plate, into 100. Okay, so here we can write delta 2L by delta L minus 1 into 100, and this value we know from equation number 4. We can write this value to be root 2 minus 1 into 100, right? So this value, the percentage change we will get is 41.42%, this value, because root 2, we know the value of root 2 is 1.4142. Okay, so now let's go back to the question and fill in the blank. So we need to find correct to 2 decimal places. So the correct answer will be, in percentage change, it will be 41.42. Now to get more information on boundary layer theory, such as boundary layer thickness and its derivation, you can refer to the NPTEL course lecture number 37, Boundary Layer Theory on Introduction to Fluid Mechanics and Fluid Engineering by Professor S. Chakravarti of the Department of Mechanical Engineering at IIT Kharagpur.